Yes, hello everybody. Thank you for sharing some time with us here. With the start of our now new seminar series or webinar series about water mist in different applications. Today we will start about water mist for power infrastructure protection. Other webinars will follow for hospital and for metro stations. Just shortly introduce myself. My name is Ralf Polwitz. I'm with company FOGTEC now for more than 15 years, and I'm the head of sales in fixed system. In today's webinar, I will introduce a little bit about and share some details about our company, some backgrounds about some testings and so on, and two case studies for very specific projects which we have done in the past in the range of infrastructure protection. Just for the start now, the overview, we will, as I said, the company introduction, we will straight go over. So FOGTEC is an owner-managed company, so owned by the management, and started in 1997. We are located in Cologne in Germany. We are, let's say, mainly a team of engineers, of more than 45 partners. Companies all over the world are sharing with us the knowledge and bringing, let's say, the product to the market as system integrators. So these are our system partners. So this means we are mainly the experts in engineering and in design of the complex firefighting and detection systems. Just to give you an idea where we are internationally located, we have own entities in China, India, and the headquarters in Germany. And if you see, we have a wide range of a partner network all over the world, including other sales channels in different places. Our business units in the company are separated into main 4 pillars. One is the fixed systems, that's the area we want to talk today. But other units are for rail systems, that means protection of rolling stock. Another business unit is tunnel systems, where we have the protection of road and railway tunnels. And as a latest new business unit, it's for new energy carriers, where we have special systems designed for the needs, let's say, of the new electric supply, like you have it in hybrid traction, or like you have it in certain facilities like parking, where you have to consider the new battery technologies. Just to give you some ideas about our wide range of customers. So you see companies like Apple or typical industrial clients like Bayer, ThyssenKrupp, or many others. So this means you can find high pressure water system in all kinds of industries and applications. Coming to the guideline work and research projects, you can see mainly, certainly we are in the main guidelines for water mist like NFPA, BDS, the SEN guideline, and so on. So many others. And certainly also in specialized things for the other business units I mentioned before. But now let's talk about our main topic of today, and that's the power infrastructure. We all know from, let's say, our own experience that the demand of energy we are consuming is growing and growing, because there are so many new technologies coming additionally. And everybody who gets his electricity bill will see, okay, there's a certain growth in the needs of energy in every kind of facility. If it's your private home, if it's your office, and so on and so on. This certainly creates the need of a refurbishment and upgrading of the power infrastructure in the country. So especially in the mega cities, there are certain, let's say, bottlenecks like space and availability. You cannot go with high voltage line, free air and crossing these mega cities. So there are certain needs, for example, to build new cable tunnel systems to ensure the power supply in these cities. Water mist is a common solution for more than 20 years now in these kind of applications. But with the growth of demand, you will see also the growth of the projects has come together. So you see still the needs of the system testing according to the EN guideline 4972, or for example, with approvals from EDS are requested. But certainly it is always a question how much this fits into these guidelines and how you can create it via these guidelines, the test scenarios, and to cover the needs of the, let's say, refurbishment projects we are facing in our times. And certainly the main topic is always have it, let's say, made easy to maintain and give a good accessibility, and certainly the reduction of the downtimes are always a big topic. As we all know, a power cut is really kind of a disaster for a megacity. For this purpose, we will today look into two different projects. One is a case study for a cable tunnel system, which we have done in the city of Singapore with Singapore Power. And the second project we will look into today is a transformer substation project in Dubai from the Dubai Electricity and Water Authorities. Let's start with the cable tunnel case study in Singapore. Singapore is still a growing city, and certainly the power demand is, let's say, growing and growing. So it's a constant, let's say, race between the needs and the supply. So that means we talk about the power to 1.3 million industrial, commercial, and residential customers they have to fulfill there in Singapore with their grid network. So they're huge investments, and let's say at the end it came to a limitation, so a complete new setup was needed, let's say a new backbone of the power supply for Singapore City, where we are, let's say, connecting the power plants, which are a little bit more outside, to bring the power downtown to the city itself. So this is done, if you can see at the map in the lower left, it's done like a T in principle, and at the end with the power stations bringing the power supply to the city where the same is needed. We talk about really substantial tunnels, which are 60 meters underground with a total length of around about 35 kilometers. You can see it's a long-term project. The first phase started in 2005, where the first power plant was connected with a 1.7 kilometer long tunnel with a diameter of 3.5 meters. And this was connected now to the city and a power station, which was a little bit more outside. At this time, a high-pressure water mist system was selected, as this has the lowest, let's say, impact on the daily use and business of these cable tunnel, and you have the chance to have a straight and open tunnel. Around about 10 years later, the next phase of this project started, and this is this T, what we have seen in the slide before, showing, let's say, an additional supply and connection with the other tunnels, with the other power plants. But now the new challenge was these tunnels had a diameter of 6 meters, and certainly in these, let's say, shaft areas, we come to a diameter up to 9 meters. Certainly, this is not a common cable tunnel, which you can cover easily by, let's say, already existing fire testing. Yes. So for this purpose, we need to develop a new system and certainly a new fire test scenario. This was jointly developed based on with the end client and certainly with the fire consultant, where we had two topics, certainly to protection of the cables and the cable troughs, and additionally the service vehicle in the center of the tunnel, yes, which needs all-time free accessibility into the tunnel. Certainly it's also important that in case of change of cables and cable troughs, all these must be free accessible. So it was very clear and tough request to have as less interference by a firefighting system as possible. On the other hand, we talk about a longitudinal ventilation of around about 5 meters per second, which is quite substantial. And all these needs to be shown and covered with these fire tests. You can see here what was the mock-up look like and some results of the heat curves and an example of a, let's say, picture. The fire scenarios were different ones. We had, let's say, some more concentrating on the cable and the oil-filled cable troughs and so on. So where we talk about more flammable liquids, but also to cover the service vehicle, let's say solid fires were requested. Here you see on the upper picture picture from the test mock-up, which was a free spray test in this case. And below you see the picture of the final installation. At the end, it resulted in a system with, let's say, around about 25,700 nozzles, where we had separated all the areas into sections of 33 meters length, where 3 areas will be discharged at the same time. In these main tunnels, you only had a ceiling installation. So this means you had no interference with the service vehicle or with the work on the cables. You can imagine with these huge cable tunnel, was also an investment for the future. It will be not fully equipped straight from the beginning. So it will always have a certain reserve left, which will be filled with cables step by step, depending on the needs and the demands of the city. So at the end, you could see that it's a free accessible tunnel. We had very small diameters, yes, so that it still have no interference, and you had an installation mainly at the ceiling. The chance and advantage was also that a lot of these steel pipe could be pre-manufactured in the factory, in the workshop. So in total, we talk about 75,000 meters of stainless steel pipe, which could be pre-manufactured for these different sections and areas. So at the end, the water supply came from 6 pump stations, which were located in different places in the city at the shafts, and giving, let's say, complete independent water supply of 30 minutes. All these pump sets were done in a 100% redundancy. So at the end, you could, let's say, generate a fire protection, which allows a complete independent working system for 30 minutes, which has an immediate and proven effect on the firefighting in the cable tunnel and reduces absolutely the downtime of the tunnel, and with the same time has no interference with all needs of the daily work in the tunnel. Let's look to the next project. This was in the city of Dubai. In Dubai, we all know it's a fast-growing city, so there's also a constantly growing demand of, let's say, power supply. And this will be distributed into the area by different substations. And there's a huge number of substations, and when we just consider that, let's say, here DEWA has to ensure the power supply to 670,000 customers, which is also a huge number, yes. So it's a constant extension of the network. So in this project, we are looking at 6 substations, which was one phase. Here, the challenge was that these transformers had an open front, or more or less up to 60% open front and roof openings. And certainly, if you look to the sizes of these transformers here shown on the slides, you can imagine these are really pretty huge transformers. Also here was the request of proven and approved fire testing. So it means it has to be confirmed by, let's say, TUV in this case. So it has to be recognized and accredited by this Dubai Civil Defense, an authority accredited by them. In this scenario, we also had to consider certain wind conditions. And if we look then to the full-scale fire test that was developed jointly, we built up a mock-up, again, one-to-one fire test, like it is common in water mist technology, where we had, let's say, to evaluate the performance. Certainly, this also was following the requirements of NFPA 750 and again the European guideline 14972 standard. So the test mockup, if you just look to the sizes, we talk about 10.5 meters in height, 8 meter width, 10.5 meters in length, 8 meters in width, and 7.5 meters in height. And there, again, with the open top, and certainly, again, the 60% front opening. And now, to make it even more complicated, we talk about, let's say, forced ventilation of 4 meters per second. So you can imagine this is quite a challenge, and especially when we talk about fire sizes up to 10 megawatt. So here we had to prove that the system is properly working. So at the end, the protection concept, that was certainly that we have to protect, let's say, the grid soil below the transformers for oil leakage, spillage, and so on. And then on the sides and on the top with rings, we, let's say, created a water mist in-housing for the entire transformer, which works pretty well also with these openings. So because here, this filling effect, yes, of the high pressure water mist was very substantial, really, to house in the entire transformer. Also, if you have some openings, the water amount and the water mist which was created was big enough really to have a quite substantial and, let's say, satisfying housing effect of the entire transformer enclosure. The activation of the system was by fire detection system. And certainly in this case, there was a special request for, let's say, a mixture of a glass bulb activation and the fire detection system. Whereby this was a customer request. In the water mist systems, you're generally flexible with the chosen detection system for the application. So the pump room itself, that each transformer station or substation had its own pump room. Here we again had a pump system with 4x 120 liter at 120 bar and a complete backup which was diesel driven. So again, here we talk about a 100% redundancy which was requested by the customer. And now the point is also here we did an independency for 30 minutes, which was generated by 15 cubic meters of water. And this was also one of the big topics that drive the decision to go with high pressure water mist, is to reduce the water mist, to reduce the water amount by using water mist. You can imagine the storage of water and certainly the treatment of the used water after a fire incident is always a big topic for a customer and always a big argument to reduce the amount as much as possible. So the system was equipped with jockey pumps, the same we had in the Singapore cable tunnel, which was pre-filling the pipe work till the section valves to have an, let's say, firefighting effect started as fast as possible. If we now look to the two shown cases we had here today, I think it's a clear conclusion that we have, let's say, very effective solution created and certainly a proven solution created by the water mist system. And certainly you see that we are able to create with water mist solutions which are a little bit, let's say, out of the standard frame. Yes, so let's say a common cable tunnel, yes, we know this is possible with water mist, but now we can see with these examples that also very special and huge applications always offer the potential that it can be solved and treated and, let's say, handled with the water mist system. And you can prove the same, the efficiency, again, by additional fire tests. Yes, Certainly, these fire tests can be used for comparable projects in the future. But you see, WaterMist gives you a certain flexibility in the, let's say, power supply projects that you have, and reduces the downtimes, the interference on maintenance, and the daily business, as we have a certain, let's say, limitation in the needs of a WaterMist system by the small pipe work and the smaller water amounts. So this, let's say, gives a certain flexibility for the systems. So I think this brings me now to the, let's say, end of this first short, let's say, session for today. I think maybe my colleague Albert had already some questions in the chat. I don't know if there were some. So my colleague Rüdiger Koch was obviously quite busy, I see from my colleagues here. So if there are some questions left, we will anyway answer the same by email. Yes, we will collect the same. So it's now just left to thank you very much for your attention, and I hope that you will join for our next webinar, which will be on the topic of healthcare. Thank you very much, and I wish you a nice day. Thank you.